Let's go through the 2369. Check if there is a valid partition for the array. For this question, it will give us integer array nums and ask whether the array can be partitioned to at least one can have at least one valid partition. That means so a valid partition means can is means it satisfy one of the following conditions. For example, if there is one part that has two equal elements, or three one part it has three equal elements, or it has three elements and they are consecutively increasing by one. So, for example, example one, right? We can partition as 4 as one part, 5 6 as the second part. So it returns true. But the second example, if we put 1 as one part, 2 cannot we cannot put 2 into another one which have satisfy any of the previous three conditions. Also, if we put 1 and then we only left 1 2, so 1 2 is not does not meet any of the previous condition, so it return false. We cannot partition to at least two parts, and each part satisfy the previous conditions. So what we're thinking about is that we have a economic length. So we're going to have a DP integer array Boolean. So DPI will mean two nums minus 1 0 2 we can partition or not. We have an extra step here because we have a BP 0 always at true, right? We don't need to, for this connectors, we are able to we don't need to try to see whether the first one is true or false. So what we are going to do is that let's say DPI so DP if we have DPI minus 2 equals true and nums I minus 2 because this is the corresponding one is nums I minus 3, right? Nums I minus 1, then we have DP I equals true, right? So this is the first condition. The second condition is if we have DP I minus 3 equals true, and 3 nums I minus 3 equals number I minus 2, and nums I minus 3 equals I minus 1, or I minus 3 plus 1 equals this one, and then right, then we're going to have BP I equals 2, right? So we can iterate from I equals 3 because I equals 2, right? This kind of I minus 3 will be a negative number. So we'll say BP 2 equals nums 0 equals nums 1, right? So we'll say for int I equals 3, I smaller than n plus 1. I plus, right? But say if dp I minus 2 and nonce I minus 2 equals nonce I minus 1, right? Then we have dp I equals 2. And we can also write if dp I minus 3 and we have a long condition. Um, I minus 3 equals I minus 2. And I minus 2 equals I minus 1. Right, this is the first condition. The second condition is the if check that, put it here. Dp I equals to that. So the second condition is that this one plus 1 equals this. Also, we need to have a parenthesis. Plus 1 equals this. And this one plus 1 for this, right? And in the end, we just return dp thing, right? Um, better operator. Oh. Let's look at this one. We need to have a actual, have another bracket parenthesis here, right? So this one is related to this, so we are missing one parenthesis. And this one should be equals, double equals. Okay, doing like this, the time complexity will be ON, space complexity will also be ON. But actually, we can have us use a ruling array to have the space complexity to be only from I minus 3 to I. So possibly just a four length 4, right? That would be, we can get this one a bit better. So the hard part for this one is that we just don't. It is possible that this array may be out of the index, right? So another way is that if we don't want to care about the auto range on the left, we can have this one, because if we I smaller than n plus one, right? So I the maximum will be n, and we are going to have I plus 3, right? So we can have this one as I plus 4, right? In this case, we can write, we don't need the dp2, right? So we can write something like, for when I equals 0, that's smaller than n plus 1, right? I plus. We can do from the just from the previous from front to the end. So we have this for dpi and dp nums I if dpi and nums I equals nums I nothing, right? Then we'll have dp plus 2 equals 2, right? And let's say if we're dti and we still have the long condition, right? And we have dpi plus 3 equals 2, right? We in this case we just don't need to worry about, we need to care about the right index. So we have n plus 4 here, and we'll have this. And I plus 1 plus I plus 2, right? We can have the long condition here, or we can have another condition. We don't just have 3 conditions, right? That's as what the problem give us. Plus 1 equals, and this one plus 1 equals. Then we return dpn. dpi okay. Here nums I, it will be out of range. Let's still keep this as a, if I plus 1 smaller than n, and if I plus 2 smaller than n, and right, I plus 2 smaller than n, and right. So This one plus one. We don't need these princess. We need this princess. Okay. Yeah, doing like this way, we need to care about either the index on the left or the index on the right, right? Of course, we can also use using the rolling array to have to save the space complexity.